Okay, hello, this is Dr. Hana Asil, and we're starting the AS Edexcel chemistry course. So this is the first lesson in Unit 1. You probably know that we have 3 units. Unit 1 consists of structure, bonding, introduction to organic chemistry. Unit 2 is energetics, group chemistry, halogenoalkenes and alcohols. We'll discuss all of this. And Unit 3 talks about experimental techniques. So these are the 3 papers that you will be required to sit for. So the first unit is basic. Most of it is from the O-level course, so plus a little bit extra for the AS. So this is the easiest unit. So the first chapter is atomic structure. This is basic. You probably know already that the atom is made up of a nucleus that contains protons and neutrons, and electrons revolving around the nucleus. The neutron and the proton have a mass of 1, while the electron has a very small mass, which we give as 1/1840. With respect to charges, you should know that the neutron is neutral, so its charge is 0. The proton has a charge of +1, and the electron has a charge of -1. Now, what is atomic number and mass number? You should remember from the previous course that atomic number is the number of protons in the nucleus. So this is the small number that you get from the periodic table. And usually it is the same as the number of electrons. Now, the mass number is the total number of protons and neutrons in the nucleus, and that is the bigger number that you get from the periodic table. You know that in an atom, the number of protons is the same as the number of electrons, and that is the atomic number, which is the small number from the periodic table. So something like fluorine has 2 numbers, 9 and 19. The smaller number is the number of protons and electrons. The number of neutrons is the difference between the mass number and the atomic number. The number of electrons are 9, so if we're distributing them, you should know that the first energy level has 2 electrons, and then the rest goes into the second energy level with a maximum of 8 electrons. You should also know that an atom may lose electrons. If it loses electrons, it becomes positively charged, because in that case it will have extra protons, and it is referred to as a cation. An atom, if it gains electrons, becomes negatively charged, and it is referred to as an anion. So F minus, for example, F minus means it has 1 extra electron. The number of neutrons is the same, number of protons is the same, it only differs in the number of electrons. So now we have, instead of 9 electrons, we have 10 electrons. So that will be distributed 2 in the first shell, 8 in the second shell. So this is the basics that we talked about last year on the last course. When we talk about elements, compounds, and mixtures, we said an element contains only one type of atom. So it could be made up of 2 atoms joined together or 1 atom alone, but all the atoms are the same type. So that's an element. A compound is made up of 2 or more elements chemically combined together in a fixed ratio. So the compound will have different elements that are chemically combined together. The mixture is made up of 2 or more substances added together and can be separated by simple physical processes. So a mixture will have different things, either they are elements or they are compounds. Okay. If you remember again from last year, isotopes are atoms of the same element having the same number of protons but different number of neutrons. So we said hydrogen, for example, has 3 isotopes. They all have atomic number or proton number of 1. So they all have 1 proton. They will all have 1 electron also. But they differ in what? They differ in the mass number. That's because they will have different number of neutrons. So these are isotopes of hydrogen. Okay, remember all of that? So let's take a look at this question. Which of the following represents a pair of isotopes? Well, let's see. What are isotopes? We said isotopes are atoms of the same element, so they can't be carbon and nitrogen. They cannot be sulfur and sulfur 2 minus, because these are not atoms. These are not isotopes. This is one atom and one ion, if you have extra negative or positive. O2 and O3 are two different elements, oxygen and ozone. But if you look at D, then D is the same element, same number of some number of protons, same atomic number, but different mass number. So these are isotopes of lead. Remember all of that? Okay. Now, the new thing this year is that when we do electron configuration, we're not going to say the first energy level has 2, the second energy level has 8. That's not what we're going to say, because they found out that actually each energy level is divided into sublevels. So the first energy level is not just one place where you have electrons. No, it is divided into sublevels. So the first energy level has only one sublevel, the second energy level has 2 sublevels, the third energy level has 3 sublevels, and so on. So when we distribute electrons this year, we're not going to distribute them to 8 something. No, we're going to distribute them into the sublevels. So we need to put electrons first in the 1s, then we go to the 2s, then we go to the 2p, and so on. Okay, so each sublevel is made up of orbitals. So instead of just saying that I'm going to divide the energy levels into sublevels, actually the sublevels also are divided into orbitals. And the orbital is a region where an atom, within an atom, that can hold up to 2 electrons. So we have in the 1s, we have one place where you can have electrons. So that is the 1s. So that is one orbital. In the second energy level, we have 2 types of orbitals. We have a 2s, which is spherical, just like the 1s, but we also have 2 p's. So the p's are dumbbell shaped. We have one along the x-axis, so we call it px. One along the y-axis, we call it py, and one along the z-axis, so we call pz. What are all of these? These are regions where electrons can be found. And each orbital can hold only a total of 2 electrons. So the 1s takes 2 electrons, the 2s takes 2 electrons, the px will take 2 electrons, py will take 2 electrons, pz will take 2 electrons. Now, the s level is only one type of orbital. So this is one orbital that will take only 2 electrons. But the p, we have 3 types of p orbitals. Each of them takes 2 electrons. That means that a p sublevel can take up to 6. Now, we also have another sublevel which we call d. D has 5 different types of orbitals. Each of them takes 2 electrons, so that it can take up to 10 electrons. The F has 7 different types of orbitals. Each can take 2 electrons, so the F can take a maximum of 14. So, talking about here, to distribute electrons, electrons occupy the sublevels in the order of increasing energy. So, we have, for the first energy level, we have only one type of orbital, that's 1s. For the second energy level, I have 2 types, 2s and 2p. Now, for the third energy level, I have 3s, 3p, 3d. For the 4th, 5th, 6th, and 7th, I have 4 types of sublevels, 4s, 4p, 4d, 4f. The order of increasing energy, they found that if I go through along with these arrows, that means I need to fill the 1s first, and then I go to the 2s and fill it, and then to the 2p, and then the 3s, and then the 3p, and then the 4s, and then the 3d. Can you see what's happening? 3d, 4p, 5s, 4d, 5p, 6s. This is the order in which we need to fill the electrons. So if we write it this way, I need to go from the bottom up, because the one at the bottom is the one that is nearest to the nucleus. This is the one with the lowest energy level. As I move away from the nucleus, the energy increases. So I need to fill the 1s first, and then the 2s, and then the 2p, and then the 3s, and so on. Each of these lines represents an orbital, and we said that an orbital can take 2 electrons, and that means I need to put 2 electrons into each of these lines that I have drawn. So let's see. Example of an electronic configuration. If he says, let us write the electronic configuration of zinc, the first thing you're going to ask yourself is how many electrons in zinc? Well, from the periodic table, the number of electrons is 30. So I'm trying to distribute 30 electrons. We go as is in that diagram. The 1s first, and then the 2s, and then the 2p, and so on. So the 1s has one orbital that takes 2 electrons. So I indicate it with 1s2. Please don't read this as 1s to the power 2. This doesn't mean 1s to the power 2. This means 1s orbital has 2 electrons. Then I go up to the next one, 2s. 2s can take only 2 electrons. Then I go to the 2p. The 2p has 3 orbitals. Each one has can take 2 electrons. So I can put a total of 6 electrons in the 2p. Now I still have more electrons. I have a total of 30. I go up to the next one. I put 2 into the 3s, 6 into the 3p. Notice that the 4s is filled before the 3d. That is because they found that the 4s has a lower energy than the 3d. So I have to fill it first before I go up to the 3d. So that is how I write the electronic configuration for zinc. Bromine. Bromine has 35 electrons. So again, I'm going to put 2 into the 1s, 2 into the 2s, 2 into the 6 into the 2p, the 3s2, 3p6, 4s2, 3d10, 4p5, because I'm left with 5. Do we understand this? Okay. Within an orbital, electrons must have opposite spins to counteract the repulsion between their negative charges. You know that each electron has a negative charge. Now, if I'm going to put 2 electrons into the same orbital, they would tend to repel each other because they have the same charges. So they have found that electrons have opposite spins in order to counteract this repulsion. And that means that no electron pairing takes place in a given sublevel until each orbital contains 1 electron, because we don't want as much as possible to put 2 electrons together. But if we have to, we will. So for example, boron has 5 electrons. Now the 1s needs 2 electrons. We said they are opposite spin. We indicate that by arrows pointing in opposite directions. So when we write arrows going up and another going down, that indicates 2 electrons having opposite spins. I put another 2 into the 2s. Again, they have to be in opposite spins in order to go into the same orbital. Now I'm left with only 1 electron in boron. It can go into the 2p. It is alone, so it will point upward. That's how we denote it. And as we go on and fill carbon and nitrogen and oxygen, we fill the orbitals that have the same energy first. So for example, nitrogen. Can you see how we filled nitrogen? We put 2 into the 1s. Then we go up to the 2s, we put 2. Now in the 2p, x, p, y, p, z, these are equal energies. So we put 1 electron into each one, and then if I have an extra electron like oxygen, then I start to pair them. Do we understand that? Okay, so iron, for example, is this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. That means that I put 2 electrons in the 1s, 2 electrons in the 2s, and then the 2p is filled, 3s, 3p, 4s, 3d. Now in the 3d I have 6 electrons. How am I going to distribute them? 1 into each orbital. Then I have 1 extra. The 6th electron is used to pair that first orbital. And that is how we draw it. So if he says write the electron configuration, we write it as it is written at the top: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. If he says draw, then we have to draw it with arrows pointing up and down as indicated. Okay, so sulfur. Sulfur again, write the electron configuration of sulfur. That is the electron configuration of sulfur. draw it, this is how we draw it. 2 into 1s, 2 into 2s, then we fill the 2p, and then we go up to the 3s, and then we put 1, 1, 1 into the 3p. I have an extra, I pair it. Okay? Now, there are exceptions. So chromium, for example, has 24 electrons. Now, how do we distribute them? You should realize that if the sublevel is filled, or if it is half filled, it is more stable. So a sublevel will tend to be filled or half filled. So chromium, for example, we were supposed to write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. That's what we should have done. But actually, that's not what happens, because the 3D would need just one more to be half filled. So we take one from the 4s and put it into the 3D. Now it has 4s1, 3d, 5. Both are half filled, both are stable. Copper also has 29 electrons. So I should have done 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. But that means that the 3d just needs one more electron to be filled. So I can take one from the 4s, and we do that only because the 4s and the 3d are very near to each other in energy. So we take one electron from the 4s and put it into the 3d, so it is 4s1, 3d10. That's how we write. Okay, so let's take a look at this question. In which of the following electronic configurations are only 2 of the electrons unpaired? So let's take a look at each one. The first one says 1s2 to s2, and that means that I have paired electrons in each orbital. Paired means 2 together in the same orbital. Now, if I draw the one in B, 1s2 to s2 to p3, I have 3 electrons that I have to put into the piece 1, 1, 1 first, and then they're not paired. So here I have 3 unpaired electrons. Here, this is where I have 2 unpaired electrons, because I put 1s2, 2s2, and then the 2p4, we said we have 3p orbitals, 1, 1, 1 into each, and I still have a fourth one that I need to use to pair the px, and that means I have 2 unpaired electrons. D has only 1 unpaired electron, so the answer is C. Okay, so if we look at the periodic table, in the different groups in the periodic table, if I look at sodium, what is the atomic number of sodium? Atomic number of sodium is 11. Now, how is that distributed? 1s2, 2s2, 2p6, 3s, 1. So the last electron is in a 3s. If we look at calcium in group 2, calcium has 20 electrons. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And that means that if we sit down and do all the ones in group 1, for example, or the ones in group 2, they all end up with S's. So group 1 and group 2 are called the S block. Now, if we look at something like scandium, Sc, scandium is 21. Scandium is a transition metal. It has 21 electrons. If I distribute it, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So the last electron is in a D sublevel. If we look at cobalt, also it is in a D sublevel. So the ones in the transition metals always end with D. So that part of the periodic table is called the D block. If I look at chlorine, for example, chlorine is 17. When I distribute it, it ends up with a P. So that area is called the P block. Neon also ends with a P. So as a result of that, we will look and find that anyone in 1s will in the group 1 will end up with 1s. Anything in group 2 will end up with 2s, and so on. And then we have, so the group 1 and the group 2 are called the S block because all the atoms will end up with an S. Now, can you see where the P block is? any elements in this area, if you sit down and do the electron configuration, it will always end up with a P. The ones in the transition metals will always end up with a D, so that is called the D block. If you do any of the ones down there, in which we call the F block, it will always end up with an F. So if you look at the periodic table, you have to realize group 1 and 2 are S, groups 13 to 18 or group 3 to 8 are P block, groups in the transition metals are D block, and the ones down there in the periodic table are called the F block. That means that when you do the electron configuration, they will always end up with an F in that block, or an S, or a D, or a P. Okay, so thank you. This is the first chapter. Now you need to look at the chapterized questions, try the questions on this chapter, and we will take a look at the answers to the questions in the next video. Thank you.